In this video I'm going to talk about RepRap Software and everything you're going to need to get your RepRap up and running. So I'm using a ramps board, and the ramps board fits on top of the Arduino Mega. It's underneath here. So at the very end we have our Arduino. So alright, pretty fancy. So our Arduino is a programmable board, and you're going to need to upload a program on here. In Arduino language they call it a sketch, but you can think of it as firmware. It's going to be the firmware in your device that your computer will write the data to this device, and then this, your Arduino will turn the stepper motors and print your thing. Alright, so we're going to have to program the Arduino using the Arduino IDE. And IDE stands for Integrated Development Environment. So you go down, download the IDE software, and that allows you to program your Arduino. Now, obviously there are other hardware you can use with the RepRap, but I think most of them are Arduino compatible. So I think you're going to be using the Arduino IDE. Now this file, or this sketch or firmware, you'll open up this sketch using the IDE, and you're going to have to modify some things. There are things like how fast your nozzle will heat, and some scaling so that your stepper motors are moving the right distance. So you will never be able to just open this up and blow it in there and you're good. You're going to have to modify this thing. You're going to be downloading it several times. So how you connect your computer to your Arduino board, you just use a USB cable, plug it in, and you'll use this to program this, but also you'll leave this plugged in when you're printing. Your computer will use this cable to control your machine. Alright, so we'll assume that our Arduino has been programmed. Okay, so you need a couple more pieces of software. You're going to need computer-aided design software. This is where you build the STL file. So you build an STL file, you open it with your computer-aided manufacturing software, fancy words, and it uses this STL file, and it uses the USB cable, and it will actuate your stepper motors and print your part. So this software is what's running on your computer that really opens the file and prints your object for you. So there's a whole host of CAM software out there. The one I'm going to use is Print Run. And then for designing the files, I'm going to show you Google Sketchup. Actually, it's not made by Google anymore. Okay, and all of these are free, so you can download these without paying for anything. In fact, you probably don't, when you're starting off, you don't need this designer, because you can use files that have already been made. You can go to thingiverse.com and you download lots of sample STL files. So you should know, if you go to the RepRap wiki, notice this URL up here. It's called _RepRap _options. This thing kind of explains the software tool chain, they call it. So like I said, there are CAD, computer-aided design, for designing your stuff. Then there's CAM for actually printing it, and here's some options you can use. I use this one right here. You can see under CAD tools there's a whole bunch of open source ones here, but there are probably some really great paid CAD tools out there as well. And then of course your firmware, which is the Arduino IDE. Now the firmware, you're going to have to download one, and the one I used was Sprinter. So basically that's the file that we load, the firmware file that we load using the Arduino IDE. Okay, from this page, let's go ahead and get all of the software we need. So for starters, let's go down and start with the firmware. So you can pick a firmware, read up on them. The one I'm going to get is Sprinter, and I'm going to use it with the Arduino IDE, but let's get this first because it will tell you what which version of the Arduino IDE it wants. So here's a guide about some of the stuff in there. Let's go out to the external link. Okay, and then we can go to downloads, and I'm going to download as a zip. Save it. But if we go back here, somewhere it says, okay, they like version 0023. So this is an older version of the Arduino software. They have a newer one out. So let's go ahead and get the Arduino software. Alright. So right now they have a version 1.01, but we can go down here and there's 0.23. Go ahead and get whichever version you like. By the way, if you get it for Windows, it just is one big file that you unzip. There's nothing to install. Let's go back to our RepRap page here. Alright, so we have the firmware. While we're at it, I'm going to go ahead and get print run. Okay, so for Windows there is a ready to run version, and you don't have to install all the prerequisites. Let's go out here and just get this sucker. I'm going to save it. Also, if you feel like it, you can go get something like Google Sketchup for a CAD program. It's pretty easy to get the download here. Okay, now that you have everything, go ahead and unzip your Arduino IDE. Mine happens to be in this directory. There's my 0.0022 Arduino library. Alright, so I'm going to unzip the Sprinter software firmware. And there is a .pde file down here you can open up. And the Arduino software should go ahead and open that file up. You can see it's got a whole bunch of different files. The one you're going to look at the most is the configuration.h. And for starters here, you pick your board. So mine is a ramps 1.4. So we need to set this thing down here to 33. I have 100K thermistors on my heater and the heat bed, so that's why there's a 1 here and here. And then the other thing is you're going to end up having to tweak these numbers so that your RepRap is printing the right scale. So you're going to start with a certain dimension object when you're calibrating, and then you measure it, and if it's too big or too small, you change these and calibrate that up so that it's printing an accurate scale. So whenever you're happy with this, I'll put some links. I have a video that gives you more information on the Arduino, and also there's a video that goes through these things one by one and will help you set it up correctly. Alright, so whenever you're ready to upload it, there's two things you need to select. The board, it is a Mega, this one right here. Alright, and then you have to pick the serial port, looks like it's 11, and then upload. When you see those flashing lights, that means it's uploading the program to it, and then it's done. Alright, so now that it's done, it says that it's done uploading here. Print one is another one of these that you don't actually install, you just go ahead and unzip it. And now we go ahead and double click this executable here. Alright, is we can start testing our connection for starters with the Arduino board. So you can go up here and say what COM channel your Arduino board is on and go ahead and do a connect. And it's successfully connected. And you can also do things like jogging the steppers up and down just to see if it works. Alright, so when you click the 1, it will move the head up, I don't know, 1 millimeter, who knows. So I'm going to go ahead and hit this button here. So you can jog it up, down, X, Y. You can also turn on the heaters. So at this point what you could do is go ahead and load a file. I guess we would need a file. Alright, so let's go back to the web page here. We'll do rep. Alright, so if we want to calibrate this thing, we need to download some files here. So I'm going to skip over this stuff and go straight for this guy. This is the first thing you print to check your calibration. I'm going to go ahead and save it. Alright. There it is. Thin wall STL, open. And then we've got it processed, and then we hit print. It's not letting me print. Okay, so we're connected. I'm going to go ahead and turn these heaters on. So my heater's set for 200 degrees C. I'm going to set it. My heat bed, set it. And then what we'll do is we'll do a monitor. And you should see this updating here with my temperatures rising. You see this heat bed temperature is rising, my hot end is rising. Of course, you need to set the correct temperature for the type of plastic. I'm using PLA, and I started at about 185, but it's working a lot better for me to heat it up a little bit more. And with different types of plastic, you know, black versus white, even of the same type, you might change the temperature a little bit. So once these things are warm, I can actually hit print right now, and it'll wait for the temperatures to hit. But I'll be patient and just let it warm up here. So these buttons are home, and what will happen, let's say the Z-axis, if I click this, it'll go down until it hits the limit switch, and that is the home position. Same with X and Y. So I'm going to go ahead and do these and show you what happens. Let's start with Z. We'll go and click. Obviously I've already got these set where I like them. You might manually set these before you hit the button because it could bind up. Alright, we'll do X. Alright, so I have this file loaded. I'm going to go ahead and hit print so you see what happens. Maybe it's waiting for the temperature to be perfect. I don't know what it's doing. There we go. It will wait for the temperatures to be right. There we go. It will wait for the temperatures to be right. So it drew a little line around first to kind of clean up the tip, and now it's printing this thin wall. By the way, I have printed a few. This was my first one. it didn't come out. I wasn't feeding very well, and there were some other settings that I didn't have right, so we'll go through a bunch of stuff in the calibration video and call this thing good. Obviously it's doing fairly good now. It doesn't look perfect. Well, if you'll notice, I burned out a few resistors on my hot end, so that's why I'm using jumper clips. I got tired of putting them back right, and now this one won't burn out, so I think I may need to order some different resistors that are a little more durable. And it is done. So, okay, so some of the sides look pretty good. This side, So, obviously I have an issue here. Whenever it comes over here, this is where it goes up a notch and then starts again. The material is really thin, so I don't know if it's backing up too much. So if we want to be able to import and export STL files from Google Sketchup, you have to get a little plug-in. So I'm going to get this plug-in right here, and the download is right here. Go ahead and save it. And here he says you put it in the installation directory in the plugins. So we'll go ahead and find this guy. We're going to copy, cut, see, program files, Google. Google SketchUp, plugins. And what do you know? It's already there. STL imported. Okay. So now we go to Google SketchUp. Let's do a import STL. There we go. So, all right, we'll open it. There we go. I am not going to go into this program, but there are tons of videos online on how this thing works.